Hey there dev friends, and welcome to the second part of Hello Obby. Today I'll show you how to make a custom jump pad using TypeScript and customize the looks and settings of your character. Going back to your scene, you'll see these platforms that we made, and we're going to move on to making a jump pad. I'm going to make one more platform here that we're going to convert into a bounce pad. So go ahead and name this something like bounce pad, jump pad, whatever you want. I'm going to scale it down and I'm going to move it over. This is going to be a space that if the character runs into, they will jump. I want it to look a little different than the other platforms, so I'm going to copy and paste the material and place it onto my green jump pad. I'm going to set this one to be transparent so that we can see through it, and slide down that alpha in the color. Alright, that's not bad. I'm going to turn off the gizmos in the top right so I can see it a little easier. And I'm going to scale down the metallic value. Another fun value is the emission value. This is color that will show regardless of the lighting. So I'm just got a little bit of green there so that it's always visible. Now that we visually have it how we want, let's go ahead and make a script that will handle the logic. I'm going to go to my project view and hit create folder just for organization to make a code folder. Then I'll go to create again, choose Airship component. Let's name it bounce pad and open it up. You can see it comes with some code by default. All this is saying is that we have a class named bounce pad. It's going to be an airship behavior. Anything that's an airship behavior is a component that can be placed onto a game object. There's a start function, which happens when the object starts, and it has a print message. If you remember, this code won't get run unless it's attached to a game object somewhere in the scene. So let's click on the jump pad, hit add airship component, and search for our script that we made. There's the bounce pad. So now that script is an instance on a game object, and when we hit play, we should see the print message for that object. Hello world. Great, we have our first bit of code running. Now we can modify that code to make it bounce the character. Let's go ahead and make a public variable for how strong of a bounce we want. If you name a variable and make it public, it will actually show up in the inspector so that you can change it in the Unity editor. If we go back to our jump pad, you'll see the bounce strength is displayed there and you can change the value. This is useful for quickly editing variables without having to edit and compile code. Another way to organize your inspector is by adding headers. So if I add a header called variables, you'll see that show up in the inspector as well. This is useful as you get more and more objects on your class. Alright, now how do we detect when the player is hit? Well, we're going to make our jump pad a trigger. There's a special function called onTriggerEnter. If you start typing it out, you can override that function. This event passes in a collider, which is whatever collider hit us. So let's see if we can grab a character from that object. We're going to do that by doing collider.attachRigidBody, get the game object, and search for the character component. This could return a character, or it could return undefined, meaning something hit us, but it wasn't the character. So we'll just do an if check to see if the character exists or not. Character.movement, which is Airship's default movement system. Add impulse, meaning we want to add a force to this movement. New vector. A vector just defines a direction. In this case, we're going to send them straight up, which is the y component in Unity. So if we add our strength variable to the y component, then whenever the character collides with this box, it will fly up. Make sure that your box has isTrigger set to true, otherwise your character will collide with it but not enter inside of it, and your function won't run. In my case, I had the collision on the cube itself, but our code on the parent transform. So I'm actually going to move that box collider up to the parent where I have the script. The onTrigger event function will only fire on the object that actually has the collider component. So I'll modify the box collider to be where I want it, make sure it's a trigger, and let's try running this again. Hey, now we got it. The character bounces up, though not very much. Let's crank that value up and see what happens. I'm going to change it from 10 to 100, and we'll see what kind of difference that makes. Hey, now we're flying. Alright, I'm going to guess that a value of around 35 is what we're looking for. So click on your jump pad, change that strength to 35, we'll test it out, and that should be high enough to get us up onto the platform. Nice. If you just want to bounce the character straight up, this is enough. But in a lot of cases, you'll want the platform to be facing different directions. Maybe you want to launch them sideways or at an angle. So let's move our bounce pad to a 45-degree angle and see if we can get the character to bounce at the angle of the actual bounce pad. If we were to play now, the character is just going to bounce straight up because we're applying a force to the character that is solely in the y-axis. Right now the character is always going to go upwards because we're passing in a raw vector that only has strength in the y component. What we want to do is take that vector and treat it as if it has the rotation of the bounce pad. Unity has a function for doing that. If we take this dot transform, which is the bounce pad's transform, dot transform vector, and pass in the vector we made, what this is going to do is it's going to assume that this vector is in the local space of our transform and convert it into a world space vector. Straight up in the box is going to go in this direction. Let's get a little visual here. But if the whole platform rotates, you'll see that this object is still just scaled in the y direction, but it's now pointing where the platform is pointing. That's what's going to happen to our vector as well. Vector math is very important for game design and maybe a little confusing. Hopefully that helped. But looking back at our code, this should now take the strength and transform it into the bounce pad's direction. But because that transform might be scaled, the strength of our bounce isn't actually going to be accurate anymore. We can resolve this by just saying we want to go upwards in this direction, but after we do the transformation, let's normalize it. Let's normalize it, which just means get this vector in a range from 0 to 1, and then multiply it by the strength we want. Now the force of our bounce won't be affected by the transform, but the direction will. If that doesn't make sense, don't worry about it. It's something you can deal with later. But just know that if you want the bounce pad to bounce in the direction it's rotated, you will have to do this. Let's test it out. Go ahead and run over and hit your platform, and you should fly off in the direction that it's pointing. You can even go over to the scene view and rotate it to whatever you want, and should be able to test it and see the results. Yeah, there we go. Let's bring our platform back towards the center and pointing up, and let's give it a little bit of polish. Let's say you want to add a sound effect whenever your character runs into this platform, a really common thing. The first thing that we're going to do is go to our script and add a new variable. I'm going to make a new header called references. These are things that we want to point to in our scene. We want to have a reference of something in our scene, as opposed to a variable that we're going to change. And the first reference we need is an audio source. So an audio source is a component that plays a sound. I'm going to add a comment here just to identify what we're doing in code. We're going to play a sound after we add a force. If I do this.audio.play, we're saying the audio source that we have a reference to, we want to play it. Going back to our platform, I'm going to add the actual audio source component, and you can see it here. I'm going to select an audio clip. I'll just use something in core that already exists. I'm going to make sure it's a 2D sound instead of 3D, but you can set it to whatever you want. You can change the volume, you can change the fall off, but for now the only thing that we need to change is this value of play on awake. We do not want it to automatically play on awake, so uncheck that. Now looking at our script, which has the audio source reference, we can actually drag the audio source component into that reference, and now our code will be able to access it. Great, it's working. Let's take it one step further and let's add a visual effect to when you bounce. To do this, I'm going to make a new game object, which is going to be our visual effects. So I'm going to create an empty, give it a name. And then inside this, I'm actually going to create something called a particle system. So if you go to Effects, Particle System, this will make a new object that has a particle system component with tons of options. There's so much you can do with particle effects. For now, we're going to keep it pretty simple. If you go to the shape, that is the shape of what is spawning the particles. I'm going to rotate it so that it points up. I'm going to play around with the lifetime of the particles, make it shorter, make them short and fast. I'm going to increase the angle of that shape so that they spread out more. And instead of spawning them over a period of time, I'm actually just going to add a burst, which is going to spawn X amount of particles instantly. Another thing I really like doing is playing with the colors. So if you do color over lifetime, you can add a gradient to the alpha, which will let the effects, the particle effect, fade in and out. I'm going to change their base color as well to something green. And if we hit play now, you'll see green particles fade in and out quickly. I'm also going to, for fun, add a gravity modifier so that they fall down over time. Crank that number up a bit. There we go. That looks good enough. So, how do we get this to play every time that you go onto the jump pad? Instead of having the game object exist in the scene, we're actually going to make a prefab in our project. This means taking your game object information, saving it to your disk, saving it to the project. If I drag that in, you see now it is its own prefab that has its own hierarchy not associated with the scene you have loaded. This is useful because now you could play many of them at once, or you could change it in one spot and have it change for all other places as well. Just to visualize that a bit, I could have many bounce effects in my scene, and if I change something in one spot, say add a cube to my effect, it's gonna change in all of these different game objects, even though I only modified it in one spot. You can also enter a prefab while it's in a scene and modify it, and as soon as you save, it will affect the other prefabs. It's worth noting though, if you change something in this prefab while it's in the scene, like deleting the cube, it does not go to the other prefabs because you haven't actually saved it to the prefab. You've just made that change in the scene. But if you go to overrides, You can either revert your change or apply your change to have it affect the rest of the prefabs. Prefabs are another important topic in Unity, and we'll definitely talk about it more in future tutorials, but that is the quick overview. Going back to our code, let's use this prefab. We're going to make another header. I like to call these templates, but you can call them whatever you want. A template to me is something that is pointing to a file in your project that you are going to use to make instances of. So in this case, we're just going to have a visual effect that's a game object, and we're going to instantiate it into the scene. You do that by using a global function called instantiate. You just say instantiate this.vfx template. So we're saying we want to make a new instance of this game object that's in our project, which is a prefab. And I'm going to spawn it at the position of this current platform. For the rotation, I don't really care about it. So quaternion identity is just saying no rotation, doesn't matter. Before we hit play, we have to link up the prefab. So if you drag that prefab into your VFX template, or if you click on it and search for your prefab, oh, you can't find it. Just go ahead and switch over to assets, which is your actual project, and you should see it. Okay, so my reference is hooked up, and if I hit play, we should spawn a new instance of it every time the character collides. Looks great. But you may notice one problem in your scene. Every time it plays, we're spawning a new instance, and that's going to keep adding and adding and adding to your hierarchy, which is not good. That's a memory leak. To fix this, we want to destroy those effects after they've played. You could do that a few ways, but here's a nice easy one. If you add a component to your prefab called easy destroy, you can destroy this object after a certain amount of seconds. In this case, I'll do 2 seconds. That seems to be enough for the effect to play. Another way you could do this is to actually grab the instance that you made and write code to destroy it manually. That would look something like this. We're going to do task.delay, which just means wait so many seconds, and then run this function. And in the function, we'll call destroy VFX, and that is enough to clear it. But since we're using that easy destroy component, we don't need to actually do this destroy call, so I will just get rid of that. Now if we play, we'll check our hierarchy, and we should see the effects spawning and then destroying. All right, we see them. Let's check the hierarchy. Great. You see the effect spawn, and then it goes away. Now that we have our level made, we have platforms and bounce pads, what if we want to customize the movement of our character? Well, let's do that right now. In Airship, by default, you're using the character system with our own graphics, but you can actually make your own variant. So I did create Airship character variant. I'm going to drag it into the folder that I want, and I'm going to give it a new name. This is a prefab that is based off the default character, but then lets you make modifications to it. It's called a prefab variant. If you double click to go into this variant, you can see the character, and I'm going to add something really obvious just to show that we are in fact using this variant. Let's say I wanted to add a helmet to our character, a nice red sphere. Sure. I'm going to remove the collider just so it doesn't mess with anything in our platforming. The easiest way to use your variant is to click on your character config and drag your prefab into the custom character slot. This is just a quick way to tell our system, hey, use this prefab instead of your default one. Nice, there's our red sphere. Although you will notice that the sphere is not moving with the animations. This is because we put the sphere in the root transform of the character. If you want it to follow the joint of a character, you can do that by navigating to the rig and placing objects specifically on the bones of the character. So I'm going to go into rig, rig. There's the head mesh, but we're actually going to try to find the head bone. So if you go down to Airship rig, navigate down, this is the actual bone hierarchy. And once I find head, I can just drag that sphere in there. And now whenever that joint moves, the sphere will as well. Because there's a lot of bones, it may be hard to find stuff. If you click at the root of the rig, we actually have a component that has a reference to all of the bones. So you can click on whatever bone you want and it'll show it in the hierarchy for you. You can also use this script to easily grab bones in TypeScript. So if you have a reference to the character rig, in code you can quickly grab the foot or the head or whatever bone you want. Alright, save that, play it, and now the sphere on your head will actually follow the animations, including if you duck or jump. But we want to do more than just visually change our character. Let's say we wanted to do something like give our character a double jump or change their speed. Well, there's a lot of components you can change. The most common one you'll want is character movement settings. These are all the settings for the default movement system in Airship. There's a speed value that you can change pretty easily if you want your character to go faster. Let's see what that looks like. And then we also want to add double jump. So if you look in the jump section, there's actually just a number of jumps you can tweak. 2. I'm also going to disable some things like flying. Everything else should be good. Now if I walk around, my speed is the same, but when I sprint, now we're sonic fast. You'll notice that the character is just sliding at that point. That's just because if you start running too fast, it starts to look like Roadrunner legs. So there's a value where if you're running faster than this specific speed, we switch to a sliding animation. But you can change where that threshold is. Let's go back into our character, and you can actually go over to the animation helper, and you'll see that there's a sliding speed variable, and just crank that up, and now you won't get that sliding animation anymore. Although I will say it can look pretty crazy if you're going super fast. Looks like I didn't set it high enough, so I'll just increase it. I'm even just going to do it while we're playing so that I can confirm that I get the right value. There we go. Now the character can run as fast as you want without sliding. I call this Roadrunner legs. And remember, since we were in play mode, those values didn't change. So if I actually want to save that, I would have to go into the prefab and change that variable again. Alright, now we have a platformer level with bounce pads and customized movement and graphics. I hope this helped. If you had any questions, please feel free to ask, and like and subscribe if you want to see more content. Bye friends.